Well, friends, so let's continue with our discussions. My screen is visible to everyone. Yeah, perfect, friends. So this is a quick introductory session on DevOps and cloud. So let's continue our discussion. I'll start the meeting. We got some more participants to join, so yeah, we'll continue our discussions in just a minute. Yeah. Yeah, friends. Yeah, shortly we'll update you. Just yeah, because even I'm really sure of the participants here today. How many of us already attended demo session and how many are new? That is the reason. First, we'll do a quick overview, just 10 or 15 minutes of overview. Then I'll walk you through the tools part, and yeah, then we get going on with that. Okay. Yeah. So, friends, how many of us are new participants in this session today? Say you haven't attended demo. Praveen. Okay. Yeah. Yeah. Okay. Well, friends, actually, this is our very first session on DevOps and cloud. But no worries, I'll give you an overview on the concepts that we discussed already in our demo sessions. Okay, I'll just walk you through and what is the plan, how we are going to conduct our classes and all that in detail. Likewise, what are the would say options we got? Meaning, if all of you are willing to join the same time 8 p.m. or if you have any timing challenges, all those I'll try to address and okay. So yeah, friends, and when it comes to DevOps, it's all about would say online participants. Please remain on mute. Once you're done with the questions, please remain on mute. Yeah, my voice is low. I'll try to speak loud. Okay. Yeah. Am I clear, friends? Now, am I audible? Everyone? Yeah. Perfect, friends. So let's continue. Others, please remain on mute. Yeah. So DevOps is all about it's all about make your software development to delivery process better, faster, and flexible. All we got to do is some background noises. Just a second, guys. Yeah, friends. So let's continue. Now, is it clear, friends? Pawan, is it clear now?
Yes, sir, it is clear now.
Yeah, well, friends. So let's continue. DevOps is all about shortening the process of software development to delivery by adapting some best practices and principles. So every software organization, they try to achieve some business needs. Some of them are listed here, like continuous delivery of a product to a client, ensuring higher quality, cost-effective solution, and reduced outages. Meaning, we got to make sure that we develop and deliver a product to a client in in a continuous manner. Within a given time duration, a software product should be delivered to a client. So this is all about organizing and managing things in the IT industry. So you are a part of, if you are a part of a project, you got to adapt a mindset that what should I do more? What should I contribute more to make sure a software application gets developed and delivered to the client in time? This is what the mindset we got to adapt when you're working in a DevOps profile. Deliver a product to a client in time, ensuring higher quality with cost-effective solutions and reduced outages. So if we try to understand these with an example, say friends, if I own a software company and I got to develop an application software to a client, what should I do? I have to make sure that I fulfill all the requirements of my client, develop an application software and deliver it to him in an incremental fashion. I got to ensure that I'm developing a quality application to my client, and I should spend less and make more profits out of the client's investment. And finally, I got to make sure that I deliver a product to my client that is, a robust application with no outages or reduced outages. Okay. And how do we achieve these organization-specific business needs? Means by implementing some software development models, a discipline of activities. And these are some of the discipline of activities we got, like waterfall model, spiral model, V model, iterative, RAD, agile, and so on. Out of all these software development models, back in the past, application development used to happen with a traditional approach, which we term it as a traditional SDLC or waterfall model. There are a lot of challenges with this way of implementing software development because there is no going back in a traditional way of software development. It all happens one step after another, and it's a one way of flow, but it's not going. The flow is not going back in a traditional way of software development. And this approach was very much adapted back in the past, but there are a lot of challenges involved, like requirements change, lack of involvement of customers or business, accuracy of estimations, and so on. There are a lot of challenges with a traditional way of software development when compared to, let's say, agile way of, or the current software development model which is adapted is agile. Agile way of software development is way much better when compared to traditional way of software development. Achieving our business needs got pretty much simplified with agile software development rather than traditional way of software development. So what is agile if we try to understand? Agile way of software development is all about developing an application software in an incremental fashion. Develop and deliver a product to the client in an iterated manner, in an incremental fashion. Not the whole product at a time, but say some product, a piece of a product delivered to the client. Again, a piece of product delivered to the client, and so on. So friends, traditional way of software development, all the activities happen in one shot or in one go. Like once the project kicks into development phase, there is no going back of changing the requirements of the client or collecting new requirements from the client. Once the project begins, there is no going back. But in agile way of software development, you have the options to collect requirements throughout the project lifecycle. Because over here, agile way of software development, there are a lot of activities that are continuous in nature. We keep on doing some activities that are continuous in nature, and that is where agile way of software development is widely adapted in the current day scenario. Clients can get started off with their businesses within a very short time frame with agile when compared to traditional way of software development. In traditional approach, we develop a whole product at a time and deliver the whole product to the client in one go. Whereas in agile model, what we do is we develop a product and deliver a product to the client in an incremental fashion, in an iterated in an iterated fashion. Yeah. And see, friends, over here towards the left, there are multiple boxes available. If you imagine all these boxes are one complete software we got to develop and deliver to a client. What we do is we don't develop the whole product at a time and deliver to the client in one go. Instead, we break that application into multiple modules and deliver a product to the client in an incremental fashion, in in an iterated manner, module by module, for every time interval. Every box of features here are assigned with a time interval, which we term it as a sprint. And once a sprint completes, by the end of a sprint, we have to develop and deliver a functional product to the client. So what is the advantage with this approach? Means client gets to know what's happening with the software within a very short time frame. Client can get started off with his business within a very less time duration. Yep. Yeah, friends. So this is what we discussed in our demo sessions, where the discussions were much more elaborated, extended. But for now, I'm going a bit faster. Okay. So give a try. If at all you missed the demo session, we'll share a recorded session of that so that you can give a try going through that detailed discussions. In agile workflow, application development happens in in an iterated manner, and there are multiple teams involved. However, even though there are multiple teams involved, if at all these teams are not working in proper coordination, delivering a product to the client in time gets pretty much difficult. So to address that challenge, and there is one more challenge in Agile, where application developed by a developer might not work the same or might not behave the same on a QA server, on a test server, or the applications might vary running from one platform to another. In such cases, how are we going to address those challenges? Again, we discussed about Docker in our demo, and I did give a clarity that we make sure that the softwares that are developed behave the same across all the platforms, and we achieve that by adapting container technology. Container technology allows you to make sure that the applications behave the same across all the platforms. Yeah, friends. So these are the concepts that we covered in our earlier demo. And today, what we do is let's get a roadmap. Okay, just let's understand a quick roadmap of the concepts that we learn in our DevOps journey. And let's understand some of these best practices: continuous development, continuous integration, continuous testing, deployment, delivery, security, all these features. How are we going to achieve? What are the tools that we're going to cover in this entire journey and all the detail? Yep. So friends, just give me a minute. I'll continue the discussions. Yeah, perfect. So what are the best practices that we are going to achieve in our DevOps journey? We try to understand continuous development, continuous integration, continuous testing, delivery, security, continuous deployment, infrastructure automation, configuration management, and continuous monitoring. We're going to achieve all these best practices in our entire DevOps journey. But before we jump in, I just have a quick question. How many of us are Telugu participants here? How many of us are Telugu participants? ఎంతమంది తెలుగు వాళ్ళు ఉన్నారండి ఇక్కడ?
Sir, I am Raju.
Okay, yeah.
I'm Telugu. I'm Maureen.
Okay. Fine, friends.
Pawan.
Pawan, okay. Fine. Well, friends, great. So what we do is today's session, it's a bit challenging for me because I have to make sure that the existing participants who already attended demo, they should not get bored. Likewise, the new participants who joined today, they should not feel quite cumbersome with all the advanced discussions. That is the reason what I do is I'll take the discussion very slow, okay, and make you understand every point. Still, if at all the new participants, if you are struggling to, just let us know so that we'll share a recorded demo session with you. Okay, but I hope this explanation definitely helps you a lot. So let's jump in and understand it. So wait, just a second, guys. What the heck is wrong? My tablet. Okay, cool. Paid application. Yeah. So friends, entire DevOps workflow, I'm going to give you an overview in this session today. Okay. Just give me a second. I'll share my screen one more time. Screen one. Screen one. Yeah, my screen is visible to everyone.
Yes, sir.
Yeah, perfect. So let's continue. Yeah, over here. See, friends, how the DevOps activities do happen in real time, and what should we know? All those I'll try to clarify and give you a quick understanding. Okay, so in DevOps, in the current organizations, application development is happening in this fashion. Say, this is a whole software. This entire rectangle here is a huge software that we got to develop and deliver to a client. Our client is, let's say, some HDFC bank. HDFC bank. Now, back in the past, we develop this entire block, meaning that entire software. We test that entire software and deliver it to the client, and it used to take a lot of time, like 2 years or 3 years. And till that point, this client should wait, because without a software, he cannot perform, or he cannot. The client cannot, commence his business, do his transactions. So back in the past, application development, used to happen this way: one whole product at a time, and that whole product tested at a time and delivered at a time. But now, as times, as technology evolved and as things got changed, now we are developing applications in an incremental fashion, not the whole product at a time. Instead, what we do is we break that application into multiple modules, and each module is assigned with some features and a time duration, which we call it as a sprint. Okay, so now this banking application, when we got to develop, what happens is initially we develop the features. We assign the features in a sprint one that are so prioritized for the bank to get started off with their business. Like, let's say this HDFC bank, they want to get started off with their business to the earliest. They need a software, not the entire software with all the features, but a software with a customer account creation feature. Next, deposits feature. Next, fixed deposits feature, and withdrawals and balance inquiry. If at all we develop an application software with these features and deliver a software with these features to the client, a client can start off with his business, welcoming his customers. Now, what we do is we understand the priorities of the client and we place them in the very first module. Let's say some 5 features to be developed. If we develop those features and deliver a product to the client, a client might start his business within a very short time frame. So such features, what we do, we assign them in the initial sprints, like 5 features initially. Let's say after that, the bank wants some more additional features like net banking for their customers. Next, phone banking. Next, email banking, and so on. They need some more additional features for their customers. So initially not required, but in the second iteration they are required. Such features again we assign them in the second sprint. So all the prioritized features are assigned at the beginner level, and let's say these are the features, how the application is broken down. 10 not so prioritized, let's say 7 some moderate features, and some 8 features which are not so prioritized. Let's say some 3 not so prioritized, and some 20 features that are not really important right at the moment for the bank to start their business. So this way, the application is broken down, and all the features that could be developed for an organization are prioritized and split this way. Now, what happens once the split process happened? Now, every sprint is assigned with a time duration that varies from 2 weeks to 4 weeks. The official duration is ranging from 2 weeks to 4 weeks. Yeah, friends, and now let's say Scrum Master set the time duration for 2 weeks. Now what happens? A team of developers, let's say initial sprint began, and a team of developers, let's say developer A and developer B and developer C. These 3 developers got started working on this very first initial sprint. Let's say developer A is geographically located elsewhere, B from, let's say, Mumbai, and C from, let's say, Canada. These 3 developers are working on sprint 1, and all their code combined together is a project. But all these developers are, working in isolation. 3 of them are, in 3 different parts of the world. Now, how do we bring forth all their code together? Means there is some, there is some platform required to get all their code together. So for that, we got source code management tools like GitHub, where all the code of these 3 developers is integrated and maintained as a repository, as a software repository. The project code is maintained, and this code we call it as the source code. And friends, again saying the source code is not of all the features in this HDFC banking project. In the very first initial sprint, developers begin writing their code, and what do? Let's say ABC, 3 developers, they have written code, and all their code should be maintained in some version controlling system, because they're all geographically located in different parts. And we got to make sure that there's a platform where all these developers can integrate their code and bring their code together as one single project. So friends, over here, developers write code maybe in Java or C or C++, we don't know, in different languages, or maybe in some of the languages they write code, and they maintain all their source code at GitHub level. And this code is also termed as raw code. Raw code. Okay. And now from here, our journey begins. We as DevOps engineers, we kick into action from here. You as a DevOps engineer, now what should you do? You have to get that entire source code written by a developer onto some build server. You got to get that entire raw code onto some machine. And what should you do? You have to perform a build activity. You got to perform something called a build activity. So what the hell is this build activity, and what happens when you perform a build activity? If you try to understand, yeah, friends, the very first step is to you should get the code, and the second thing you got to do is perform a build activity. What is a build activity means? As we know, we've been hearing since ages that digital devices, like your laptops, your mobile phones, smartwatches, and all these, they understand only binary language. They understand only binary language or machine language. But the source code written by developers here is in plain English. The raw code here, or the source code written by developers, is in English, which machines do not understand. Machines understand only the language of their, only the language which is either binary language or machine understandable format. Now, what we got to do is we have to convert the code written by a developer in plain English format into machine readable format. So for doing that, we got to go through some process called a build process, where compilation happens, and all the compiled files are grouped together as a package. Build is a process that compiles the source code written by developer into machine readable format, and that code is all that machine readable instructions are grouped together as a package, as a software. So this is what happens when we perform a build activity. A software package gets created. But remember, friends, a build activity is all about converting the source code written by developers in plain English to machine readable format. There are a lot of files generated, and we got to get all those files grouped together as a package, as a software. We do that with the help of some build tools, like we got build tools like Maven and Gradle and so on. It all depends again based on the language developers are writing code. If a developer is writing code in Java, we got build tools like Maven and Gradle. If a developer is writing code in, let's say, .NET, the build tools we got are NAND, MS Build. If a developer writes code in a Ruby programming language, there's a tool called Rake, using which we got to perform this compilation activity and packaging activity and create a software package. Once the package is created, then what are the activities to be done? We got to perform a code quality check. Okay, we got to perform a code quality check on this application and understand whether the code written by developers for this package is in is according to the coding standards or not. We got to perform a code quality check and understand whether the code written by developers is according to the coding standards or not. So for that, we got tools like SonarQube or Jacoco plugin for Java code coverage. Using these tools, what we do, we try to make sure that the code written by developers for this package is according to the coding standards or not. If at all the code written by developers is according to the coding standards, if yes, then what we got to do is we got to deploy this application into some particular repository management services like Nexus or JFrog. We got to maintain those applications into some repository management servers like Nexus or JFrog. Bring this artifact and deploy or maintain this artifact or software in Nexus or JFrog. So friends, here I want to make one thing clear. GitHub is a platform where you maintain source code or raw code. Nexus or JFrog is a platform where we maintain executable files or binary files. Executables or binaries. Okay, only when this code quality check happened, and if it is yes, things happen this way. If it is no, developers got to rework on their source code and maintain the code according to the coding standards. If yes, well and good. If it is no, this code quality is not met, then developers got to rework on their code and they have to again regenerate their code according to the coding standards. If yes, not a big deal, what happens? The application is maintained in Nexus or JFrog artifact. Once the application is deployed into some test and into Nexus or JFrog, over here, what we do, we got to deploy that application into a test server to test the behavior of the application. So there's a QA team into which we pull this image and the software, and a QA team should test this application. And again here, friends, if at all there are challenges with this application, what happens? A QA team routes back to development team, asks them to rework on the source code written by them. Again here, QA, if the application is not up to the mark, the application developed by developers, there are a lot of bugs, challenges identified. What should happen? A QA team rejects the application, and again, developers got to rework on the application. If at all the application is succeeded and the application is absolutely fine, what happens is the application then gets deployed into UAT, and again another testing phase or a pre-production stage. Pre-production stage UAT, where some more tests do happen with they happen with Cucumber as a tool, and ultimately once the pre-production stage is also over, the application then gets released into production environment. Yeah, then the application gets released to production environment. Now, friends, all these activities should happen for the sprint one within a matter of, let's say the sprint duration is 2 weeks. Within a matter of 2 weeks, all these activities should get completed and a functional application should get delivered to the client by the end of that sprint. Right now, you try to understand how difficult it is to manage all these things when there are multiple teams involved, when there are multiple processes involved, and there are multiple challenges involved. You try to understand, get an overview how difficult it is to build this entire pipeline of activities, making sure that the verdict or the final outcome should be the functional product should be delivered to the client by the end of a sprint. Once sprint one is completed, again the team, they begin off with sprint two. They start writing code for sprint 2, and the same pipeline of activities continues for sprint 2, next sprint 3, sprint 4, and so on. But friends, over here, all we got to understand is at any cost, no matter what approach do you adapt here, what sort of best practices do you implement here, you got to make sure that at any cost, the releases should happen. Releases ensuring quality. You got to achieve this at any cost. Make sure software releases happen in time, ensuring quality. So how are we going to build this entire pipeline, and how are we going to perform all these activities and meet our challenge or meet our, I would say, requirement, which is releases ensuring quality. So the other day when we discussed our demo session, I think I did show you a quick video, a YouTube, what's a session. Just give me a second. Let me get that up again. So friends, I believe you might know this game, right? A domino game, where we place a stack of all the dominoes, and you touch one domino, that collapses, that falls onto another one, and that falls into another domino, and so on. Yeah, friends, just a second. Let's watch this one more time. This quick video. See what's happening here. What's happening here? She touched one domino, and that is it. All the stack or all the pile of dominoes that are set in a queue, everything's falling on top of one another, and what's happening? The journey continues till the end. All these dominoes fall on one another, and the entire structure gets collapsed. So it seems to be what say an eye feast, but just imagine how much effort they might have put in constructing this entire domino structure. They might have put a lot of effort in arranging everything, right? And they should be very cautious here, because if at all a slight disturbance happens, that entire structure gets collapsed. Likewise, now you got to perform the same, meaning all these pipeline of activities, you have to arrange them in a very well organized manner. If something goes wrong and no one's getting notified, the project might remain not traveling to the next stage. And the time is very crucial here for us. Like we got only 2 weeks of time to make a release, or we got only 4 weeks of time to make a release to the client. Right? If at all the activities are not happening as expected, if at all there's a breakage in a pipeline, what happens? The project is not jumping to the next level. So how are we going to make sure that all these activities happens as expected, and we get a desired result? Make sure that releases happen in time, ensuring quality. How do we really ensure of achieving this at any cost? Okay, friends. So for that, as a DevOps engineer, you have to adapt a problem-solving mindset. You got to adapt more principles and practices to speed up this process. Where is a clogging? What are the outliers? What are the blockers in this process? Where the project is getting delayed? What should I do? What sort of knowledge or activities should I apply here to make sure that this entire process happens smooth? So you got to adapt a problem-solving mindset. It's not about learning technology. It's not about learning Kubernetes or Ansible or Terraform. It's all about how do you make sure that this entire process happens faster and yields the expected result, releases ensuring quality. Okay, so for that, we are enrolled to DevOps course, and we got to go in a structured manner, learning all these concepts. First, we should understand from this perspective how developers write code and how do they maintain their source code at Git level. Which branch of code should I pick and build the project? On which branch should I perform, CI and CD activities? All the activities that we listed here are termed as continuous integration and continuous delivery activities. So where should I begin? How developers make their code, write their code? And we got to have some good understanding on Git too. How should I automate activities over here? As soon as a developer write code, I should immediately get notified, and the process of software development to delivery should begin. So how are we going to achieve or add such automation? We should have a very good understanding of. See, friends, again, the other day, I think I did show you a quick project. Let me again get this project for or newcomers. Oh, great. Yeah, friends, let me jump to my AWS account, console AWS Amazon.com. We got some project readily available. Wow, great. Five three one 94. Okay. 453 Right. Yeah, friends. So I did set up a pipeline of activities. Let me show you the way how what say that domino structure collapsing is an eye feast. After you set up your pipeline and once you start that pipeline, you find very what say engaging with all the concepts that happen in your process. You get automated email notifications. If something is going wrong, you get immediately notified, right? The activity, once some activity is successful, that activity kicks another activity and so on. You definitely find all these concepts which are happening in a proper arrangement pretty good. But the problem is we should have enough patience to build that entire pipeline. Okay, at times it's intimidating. We keep on constantly getting failed, rejected, but still we should continue understanding this the problem and get a solution to that problem at any cost. The only thing that bothers us in the entire DevOps journey is the time duration. We got to make sure at any cost we should complete all the features that are assigned in the initial sprints. If developers are not writing code and they haven't developed multiple features, let's say, friends, over here, developers were able to develop only some 4 features out of 5. They did develop only 4 features. Now, what happens based on the decision of a product owner? Should we deliver an application with those 4 features, or we got to complete all the 5 and deliver them back to the client, or deliver the functionality of these 4 features initially and add the incomplete work to the next sprint? All these are decided again by your Scrum Master and your product owner. If some feature is not completed, should we stop the entire release process for that sprint, or should we continue and make sure that the incomplete tasks should be add as backlogs to the next sprint? All these, since you are a part of when you are a part of a DevOps profile, make sure, friends, you're not just part of some CI/CD job, or you're not just a part of doing some build activity. You got to adapt a mindset that what should I do to make sure that the process, the product gets developed and delivered to the client in time? What should be my role, and what can I contribute more to make this release happen in time? This is what the mindset we got to adapt and get going on with. Okay, so now have a look, friends. Over here, I did create some Jenkins job. Let me just go run it. So let's connect to a Jenkins server. Public IP address. I'm glad to show you multiple approaches, multiple jobs. But as we progress in our DevOps journey, I'll make sure I'll teach you a lot more examples in detail. Okay, we go through a project-oriented training approach. So I'll make sure that you understand everything, every concept in detail. Okay, we provide you with assignments. We provide you with lots of class notes where you got to make sure that you got to give a try on the assignments, right? Follow up the class notes. Even weekends, we conduct sessions where you should be a part of and engage in some projects. You have to contribute, and you got to be an active member too. So make sure, friends, you are make sure that you're all engaged and you get the most out of this course. So over here, okay, courses Azure DevOps and AWS DevOps. We'll discuss. I'll give you an overview. So over here, what happened? A project got failed, and what happened? For every failure thing, I did enable email notifications, and immediately whenever the project fails, I get notified on my other email address. Let me show you. DevOps is all about enabling communication, collaboration, and automation. See, whenever a project fails, immediately I get notified here that project got failed. See, a project got failed. So what should I do whenever I get notified? I should immediately jump into this project, understand what is the problem, identify the problem, get a solution to the problem, and make sure that the problem is fixed. So over here, it says that a bit failed because of some command. It is not a valid command. Yes, some command we give here is not a valid command, and that is the reason the project got failed. Or if we look into some detailed logs here, build number 10, we get an overview that why the project got failed. I think it's because of some command. I did add a command which is not a valid one. Somewhere here we get notified about that. See, mvn package command, it's not a valid one. That's the reason the project failed. Now, what should I do? If at all I'm able to fix that challenge, I'll jump into my GitHub account and get that project fixed. So github.com, let's go to github.com and get that project fixed. Sign in. Now let's fix that and get our pipeline up and running normal. So the project that we worked on is the Nocturnal DevOps project. Was that it? We just check. Project 1.git. Okay. Project 1.git. It's not this one. Project 1. Look. This is the one. No. No, friends. No. I think the problem is with the source code management thing. The Jenkins project one. Yeah. Perfect. Let's go click on this URL. Why not waste time? Just go here. Jenkins project 1.git. In this Jenkins file, I did a mistake. So let me correct it real quick. Edit and let me just say steps here. Ambient package psckag and commit the changes. And once I commit a change, once I do a change, what happens is I did automate this project. In such a way that whenever the project fails and you correct it, after a minute, the project immediately gets gets built. So let me show you. Let me just go and public IP colon 8018. And once we log into the project, once we log into Jenkins, what happens is this project gets automatically built after 1 month. After 1 minute. So it got built 3 minutes ago. It got failed, and now after a minute passes, what happens is this project gets automatically built. And I get email notified that the project got built successfully. Since we corrected everything, all the steps that are involved in this project gets happened successfully. Say, have a look, friends. I did nothing. And if I go to my email and if I refresh my mail, I start getting emails here. Just a second, guys. See, source code successfully got cloned. And again, if we go back, refresh, we find a build is successful, something like that. So build successful. Next step. The next step is to deploy the application into a test environment. But that should be done under the supervision of some manager. And see, a mail to be sent to manager, and they got to log in and they have to perform an activity. So every that the project, whatever is happening there, whenever there is a glitch or whenever the project is getting failed, we are getting immediately notified that the project failed or the project is successful, or some user should log in and take the project to the next level. So this way, we're getting more and more activities done, and for every activity we're getting notified. But friends, as said, watching this process is an eye feast. But if we look into the underlying code or syntax, what did I do to perform all these activities? If you try to understand, have a look, friends. This is what the source, this is what a pipeline I have prepared. Not to scare you much, but see, this is a pipeline that we've written to make sure that all the activities happens one after another. Okay, all the activities happen in a sequential manner. Okay, of course, this is a very limited pipeline, but as we progress, as we add more and more steps to a project, like doing a code quality check, adding pre-production stage environment activities, and so on, scheduling nightly builds and so on, your pipeline code gets much more extended. Okay, but for now, it's a simple project where we're doing a very basic set of activities that are We take the code written by developers onto a Jenkins server. We perform a build activity. We take the code from a Jenkins server, we perform a build activity, and we deploy this build into a test environment. That is it. Very basic example, and just wanted to show you this. These are the activities that we did with that simple project. But when we add more and more and more complications, what happens? The project definitely gets, meaning the pipeline code gets more and more extended. Yep. So the overall idea here, what I want to stress and say is, you got to make sure that no matter what part of project you are in your DevOps journey, whether you're a developer or you're playing the role of a QA person, whatever you are, you got to adapt a mindset that what should I do? Make sure that a product gets developed and delivered to the client in time. Okay. And yeah, friends, questions here? Someone got a question? Please go ahead.
I have one question.
True. Yeah, we do that.
Like by do this code deployment, is it only linked to GitHub or it's moved to next step?
Sorry, come again.
What scenario you showed just now?
Yeah.
Is it to only changes? What are the code changes we have done? It was deployed to source, means GitHub. Is that only, or is it moved to a second build stage?
It moved. We made a change at GitHub level, and from that change, a build process again began with the corrected command Maven package. So once you do a change at GitHub level, yes, of course, it gets flown again back to your build server. It gets updated.
Okay. Build. It is a final stage is build only, right?
True. Yeah.
Thank you.
Build process. Yeah. So friends, not to scare you with all this discussion right away, what did I do? I did not add I did not add Kubernetes discussions, or haven't shown you a pipeline with all, the entire set of activities. But as we progress, we got to perform a lot of activities to fulfill this, workflow. What are those activities we got to fulfill? Let me show you. In this entire DevOps journey, we have to adapt some best practices. What are they? The very first thing is, in order to perform these activities, you need servers, you need infrastructure. So in order to get infrastructure, what we do, all the activities that we do in our DevOps journey is on the cloud platforms like AWS or Azure. So in order to set infrastructure up at the cloud platform level, we learn a tool called Terraform. So using Terraform as a tool, what we do, we write a script. And once we execute the script, once we invoke the script, the entire infrastructure necessary for your project gets created. Okay. And once the entire infrastructure is created, what we do on that created infra, we got to perform configuration management activities. Yeah. First things first, we got to understand how to create infrastructure, because whatever the activities as a DevOps engineer you want to perform, you need infrastructure, you need servers, you need networks, you need storage, RAM, CPU, resources, hardware resources and all. So whatever the resources are required, we got to opt them from the cloud platform. And for that, what we do, first we learn a tool called Terraform, and we start writing Terraform scripts. So since you write infrastructure in the format of a script, we term it as IAC, infrastructure as code. This is one of the best practices. Why infrastructure as code is one of the best practice means, when you create infrastructure, you have your infrastructure as code document as the source of truth. Now say at some point of time, someone changed your infrastructure, but you know that you are the one who created infrastructure with some source of code and infrastructure as code, and that code acts as the source of truth to show that you created infrastructure this way, but it got modified later. Okay. And not only that, for version controlling, for creating the same infrastructure for other projects, what we do, we write code by a tool called Terraform and automate the infrastructure. The advantages with this is you can write code once and consume it several times. Repeat the same infrastructure with little or more modifications in another regions. And thirdly, the infrastructure as code, that script acts as a source of truth for you to make sure that the whatever you created is something, but later on it got modified by some other user. Next, followed by Terraform, we got Ansible as a tool using which what we do, we got to configure the servers. So friends, let's take a quick example. Let's relate this way. Now you wanted to take your families. Let's say there are four families together wanted to have dinner. So what you did is you booked a reservation in a hotel. Okay, in some restaurant you booked a hotel, 4 tables. Now does that satisfy your hunger? Just booking booking 4 tables, is it sufficient? Does that satisfy your hunger? Definitely not, right? We got to jump in, occupy those tables, and then order food, get food, consume it. Then our hunger gets satisfied, and that is where you are justifying to this activity. Likewise, now Terraform is a platform using which you are preparing. Just think of that. You are reserving some servers and infrastructure. That is it. Now, to perform your activities, you need to do configuration management. Now, say, friends, there is a development team. They require Java here as a tool to perform some activities. Some QA team, they need some platform here to perform test activities. You, as a DevOps engineer, you need a Jenkins server to perform CI/CD activities, and so on. So now, to perform all these activities, what should you do? You have to perform configuration management and configure all these servers with the necessary packages and libraries. So for doing that, again, we write code, and this code here is in YAML format. We call them as playbooks. And what we do, we maintain our entire configuration management with a tool called Ansible. So initially, you got to understand, to set your infrastructure, to perform your CI/CD activities, what are required for us? In the first place, infrastructure. In the second place, on the created infrastructure, some applications. And then in the third place, you get started off with performing your continuous integration and continuous delivery activities. So for performing CI/CD activities, what we do, we learn a bunch of tools like Jenkins as a tool. Right? Next, Maven for Java-based projects we'll explore. Next, SonarQube as a tool to perform code quality checks, whether developers have written code according to the coding standards or not. We analyze and perform code quality checks with SonarQube. Next, we got Nexus as a tool to preserve artifacts, and then Tomcat as a tool to deploy the applications that are in Nexus and make sure that QA team tests the applications by accessing them from Tomcat. So learning all these tools, we do a simple project. Okay, and all these tools we configure by first creating infrastructure with Terraform and configuring the created infrastructure with Ansible as a tool. Yeah, so first set of activities we do are these: learn Terraform and Ansible, infrastructure automation and configuration management. Second, on the created infrastructure, we got to perform CI/CD activities on the code written by developers. Developers maintain their code in some source code management tool like GitHub. And from that GitHub platform, you got to adapt the source code and perform CI/CD activities. And at times, as you progress as you add more and more experience, let's say if you're adding 5+ years of experience as a DevOps engineer, even this activity of setting up a GitHub repository, giving access to your developers, even this job this job is also a part of yours. GitHub administration, you may be a part of that too. Okay, so based on the amount of experience we add, responsibilities keep on getting added more and more. So friends, remember DevOps when we are learning DevOps, we got to adapt a mindset that our job is not over until the point the release happens, the release of an application happens. We got to continuously leave updates to our teams. What is the task assigned to us? How far we came, and within what time we should complete the task. So you are more into managerial activities as well as you are more into technological activities too. We got to balance both of them. Okay, And moreover, you have to make sure that you contribute a lot in this entire journey. So this is not a platform that is only for people who are from IT background or people who did only computer science. DevOps is open to everyone, but the only thing is you should hold your patience setting up this entire pipeline of activities. Understand what are the skills that you should learn, where to implement them. That is important. Okay, so first we'll understand infrastructure automation. Next, we'll understand configuration management. Next, we do a project with CI/CD, Jenkins, Maven, all these tools integrated. Followed by that, we got to understand the importance of containers. Container application. Why containers are ruling the world? What exactly is a container concept? So we should understand and explore containerized applications concept, microservices applications concept, and followed by that, how to make your executable file here, an executable file, how to convert it into a containerized application, how to make that containerized application highly available. These are the concepts. This is how you got to learn DevOps and understand the entire process workflow. So this is where we get, introduced to Docker as a tool. This is where we understand Docker Swarm as a tool to maintain containerized applications running all the time. High availability or reduced outages. And again, for high-level application deployments, we learn Kubernetes as a tool and understand that how to maintain a containerized application always run. Yeah, friends. So I'm not discussing them right away, container technology right away in detail, but as we progress, you get to understand them as well. Okay. So containers concept. Followed by that, we understand how to maintain our servers. If at all some servers are running out of resources, how to identify them right at the beginning. If at all the project in this project here, some servers got overwhelmed, meaning they're some resources are overly consumed. Some of the servers are getting failed, maybe because of storage or because of some process running in the backend. That is, the servers are not behaving as expected. In such cases, how are we going to identify those challenges right at the beginning? For that, again, you got to make sure that you enable proper monitoring on your entire infrastructure. Enable proper monitoring, make sure that the servers are running fine, they're not running out of resources. You got to ensure all of them by enabling proper monitoring on your applications as well as servers. For that, we learn Prometheus and Grafana as tools and always make sure that the servers are equipped with enough resources and they're running fine. Instead of taking reactive measures, letting an application or server fail, and then troubleshoot the issue and again get the project back to normal. Instead of that, what we do, we take preventive measures. We make sure that applications and servers are running fine by enabling continuous monitoring on the servers. This is also one of the best practices. See, friends, if we go to DevOps best practices, you understand that these are all the best practices that we got to adapt. Continuous development. As you know, development is a continuous activity, right? We're breaking the entire application into multiple modules. Development happens continuously, sprint by sprint by sprint. If at all client wants to make some enhancements to his requirements, yes, it is possible, right? In Agile, we have software development. We're saying Agile understands all the requirements cannot be collected by the client right at the beginning. If a client wants to make changes to his requirements, yes, it is accepted. Because development activities are continuous here. Developers keep on writing code continuously for every sprint, right? Next, continuous deployment. This is important, right? What is the difference between deployment and what is the difference between continuous delivery? There's one more major question asked. What is the difference between continuous deployment and continuous delivery? So to understand this, let me give you a quick overview. If at all this entire process of software development to software delivery is automated, that is continuous deployment. If at all the entire process of software development to software delivery is automated, even the release of an application to the client is automated, that is continuous deployment. But if at all we add constraints, the application is not delivered to the client in an automated manner, but with some manual intervention, If these activities are happening, that is continuous delivery. Remember, friends, if everything is automated, including delivery, that is continuous deployment. If at all there are some constraints added, the approval of some manager or so, and a release should happen, or someone should kick in and perform an activity, then only a release should happen. If we add such constraints, that process becomes continuous delivery. Okay, so we adapt that to continuous deployment at times and continuous delivery at times. Integration, integrating multiple tools. Again, a quick example here. Let's say if we are a part of the domino game and we are stacking things. Okay, this is one domino, this is the second one, this is the third one. First one should fall on second, second should fall on the third one on the fourth one, and now I'm placing the fifth one here. Do you think the stack game continues? This domino game continues? Yes or no?
No, sir.
No, why not? Why not, friends? Why not here?
There's a gap between this one and that.
There is a there's a huge gap between this domino and this one. So the fourth one collapses over here, and this remains untouched, right? So such outliers you got to identify whether you are planning everything properly or not. Are you integrating the tools to perform their activities one after another or not? Or is there any outlier, or is there any what's a blocker here that's not letting the process to continue? You got to identify and accordingly bring solutions here and reduce that software development to delivery process. Okay, continuous integration, integrate your tools, integrate your activities, and make sure that the process continues. Infrastructure automation we discussed already. Testing, continuous testing. If at all your organizations are adapting an approach called TDD, test-driven development. Some test cases, see friends here, a development team writing some source code and maintaining here. Before a developer writes code, what happens is a test team, even they maintain their, test cases for this application in advance. Now, all you have to do is, after a build process, you create an artifact, a software package, and now you have to bring those appropriate test cases and run them on this artifact. Automated testing. Identify the appropriate test cases, bring them and execute them on the artifact so that you got to find again whether these test cases are compatible to this artifact, well and good. If not, again, route back to development team, the test result, and developers should rework on that code. So continuous testing. Configuration management, configure the servers with necessary packages and libraries and set your environment up. Continuous delivery, just before we said, delivery is all about, deploying or releasing an application to the client with some manual intervention. Monitoring, make sure that the servers are equipped with enough resources and instead of taking reactive measures, make sure you take preventive measures. Now, friends, we find this symbol frequently. Where do you find this symbol, friends? Let's say E and F. Where do you find this symbol?
Fuel gauge.
Fuel gauge, right? What is this fuel gauge? It gives us an indication that whether the fuel is full or empty, right? It's a kind of an alert system that gives you an update whether your car or your bike is equipped with enough fuel or not, right? If at all this gauge is completely towards the left, then what does that mean, friends? Time to, yep. If at all your car, when you started your journey, it's showing the gauge this way. What does that mean? Time to refuel, right? Time to fill up. If not, let's say I'm just not bothering, not considering at all this fuel indicator. I'm just commencing my journey. I might end up in some random location where, again, in order to get my car back into running status, I might have to go with I might have to go, call up a recovery van, take the car back to some petrol station, fuel station, fill it up, and then continue. Meaning, even though you're, let's say, if you're overruling, some of the warnings that are imposed, what's happening? You're just troubling yourself, right? Likewise, a continuous monitoring when enabled, What happens? We get to know whether the servers are equipped with enough resources or not. And accordingly, we take some necessary actions. If you ignore them, if you do not enable any monitoring, let's say a main core server here, Jenkins, if it is dead, yeah, friends, if it is dead, what's happening? The entire automation system came to a halt. Let's say you jumped in and you, you again troubleshooted the issue and again got it back to normal. But the time took for that entire process is 1 day, let's say. What's happening? Out of this 2 weeks of duration, 1 day, for unnecessary, monitoring, it went off. Right. So, friends, understand the severity here in DevOps that we got to make sure at any cost releases should happen in time, ensuring quality. Right. And we got to adapt cost-effective solutions. So, how to adapt cost-effective solutions? By switching to some cloud platform, Azure or Google Cloud Platform or AWS. Okay. So, accordingly, whatever the course you're opting, we are going to teach you that sort of DevOps, AWS DevOps or Azure DevOps, right? Security again, since there are multiple servers involved here, when you move applications from one server to another, or you enable communications between servers to servers, you have to make sure that the communications are encrypted. SSH keys, right? Authentication factor, very important. Others should not gain access to your servers except you. They got to set up proper firewall rules, security and all. How to do that too, we'll understand. And these are all the best practices that we got to adapt in our DevOps journey. Yeah, friends. So the time is 9:10. Let's wrap it up for today and continue again in the later session. Since it's a quick introductory session and
Sir, down the line we are using Azure DevOps or AWS.
Again, that we have to identify, because there are some participants who are from non-IT background and who are already working and they're of Azure platform. Some of them are, from opting for AWS. So we got to filter out and accordingly schedule Azure DevOps or AWS DevOps.
Me looking for Azure DevOps, sir. I'm not that much expertise.
Yeah.
I want to. That's what I talk with salesperson, with management.
Fine. Just check with the management. They'll update you about.
Okay, sure, sir. So if Azure means you will be teaching, sir.
Yeah, I'll teach Azure and AWS. Currently, my projects are all into Azure only, so no worries. I'll teach both.
Sure. Timing is the same timing, sir. Azure means.
That is what. Again, we'll get back to you.
Oh, sure. I got it. Sorry.
Yeah. And friends, did we find the session in somewhat useful, or we went a bit faster?
Useful, sir.
Okay. Yes. Yeah, Docker and Kubernetes. See, some concepts I did not explain, but as we progress, we'll get to understand this. Okay. So our trainings are completely based on real world use cases only. So just before we had a session where the session was all about shell scripting concepts, and the concepts that I covered for them as examples, if you go through, just they're beginners, but still what we did is how to write shell scripts that are related to your DevOps activities is what I did show them. Let me show you too. So, yeah. Yeah, we do cover. Those are the basic prerequisites. Without discussing them, we cannot go forward. Right. So the weekend classes, we spend some time learning Linux concepts and shell scripting concepts. Okay. Weekday classes, we continue with regular DevOps discussions. Yeah, mostly 3 months now. Taking the bad weather conditions into account, yeah, mostly it might take 3 months of time to complete. Yeah, daily 1 hour to 1.5 hours. It varies.
Sir, will you be teaching AWS and DevOps, AWS and Azure for both, sir?
Based on, we will get back to you, and based on the participants, what say count, like how many are interested to AWS, we split them to AWS batch, and people who are into Azure, we'll teach them Azure DevOps.
I'm okay with both, sir, but first preference is Azure. Why?
Azure.
Because my current project is my one Azure, sir. But
Yeah,
I'm okay to learn both.
Yeah, even though, see friends, one quick thing, no matter whether you're enrolled to Azure or AWS, remember that your organizations expect you to have cloud exposure. They don't say AWS, or they don't simply say Azure. Or let's say, if at all you are selected for a job and your job is completely into AWS, we cannot guarantee you that your job will forever continue on AWS cloud. Your client might request, the infrastructure to be maintained on Azure cloud. Then what to do? At that time, again, you got to enroll for some other course and learn. So instead of that, we teach you some use cases. If at all you're enrolled to AWS DevOps, some use cases I'll show you on Azure as well. The
Sure, sir,
entire
but
Kubernetes.
here, why I'm saying, in my perspective, Azure means,
Yeah.
here that we have a client is Microsoft.
Okay. Yeah.
From Redmond.
Perfect.
That's why I'm curious to learn that Azure first.
Perfect. In that case, nothing doing. We got to go with that. Yeah.
That's it, sir.
Yeah. So if you have an offer in hand, definitely I'd suggest you to go with Azure. But
not offer, sir. Currently
Yeah.
working for Surface devices, Microsoft.
Yeah. If at all you're willing to take some challenging, DevOps as a challenging one, I would suggest you to go with AWS DevOps, because here you get more exposure on installing everything from scratch, everything you do on your own, your operational activities and all. But coming to Azure, what happens is Azure DevOps is offered as a service. Everything is ready-made, and all we got to do is implement solutions in the cloud. Even AWS offers you that, but what we do is we prefer to teach you all the operational activities first, and then the automated activities. And in this process, you'll get exposure on Google Cloud Platform too. I'll teach you entire Kubernetes on GKE, Google Kubernetes Engine. Okay. Yeah. So friends, well, I understand, and don't worry. These are introductory sessions where I'm going a bit faster, but I'll make sure I'll slow down, and I'll give you an overview. Yeah, we got to create an AWS account. Yeah, I'll show you in the later classes. True. First things first, we got to understand how many of you are willing to continue. Accordingly, we plan a schedule. Again, we got to sort out people who are interested to Azure and AWS, and accordingly, we got to go forward. So, few challenges and some of you are already working professionals, some of you are students, some of you already attended demo, and some of you are new joiners. That is the reason this session I try to address all of you. That yeah. Yeah. Yeah, I did add my number, Shabina. Just give a try. You can reach out to me so that for any information, if you're not getting from them, just reach out to me so that I'll help you out. Okay. Others friends, yeah. WhatsApp group is created, not right away. Maybe in the future, once we are enrolled, we'll create a WhatsApp group, and you'll get every sort of update from from our management, right? But yeah, friends. So just in case if you're having any questions and you're not getting any response from the management, try to reach out to me so that I'll definitely address your queries.
Sir, how to reach out to you, sir? Directly come to institute or any phone number or mail?
I did ping my number here, so you can check with me. in the chat window. Yeah, friends. So others, you can reach out to us directly from the management. Management will get back to you, and they will, give you enough insights of how to get enrolled to the course. Okay. Yeah. We do provide you with recorded sessions every day. Once the classes are over, we'll provide you with recordings access, and just a second. Likewise, the documentation too. I'll provide you. Yeah, I'll provide you with complete documentation. The documentation is provided this way. Let's say in soft copies. So this is entire Docker documentation where we simplified everything for you, like use cases as well as solutions. Likewise, Linux documentation, everything we provide you with. Once the course commences, we provide you with all this, proper documentation as well. Yeah, coming to the recordings, yes, we provide you with recordings as well. Let me, yeah. Yeah, so this way, friends, you get all the recorded sessions from our end. Date-wise, what are the concepts we are covering? Everything we'll provide you with. Yeah. Yeah, for some of you, what say, I'm not giving my number because you just check with the management so that they will reach out to you, and they will, as we progress, definitely I'll be there in the WhatsApp group with you so that you can communicate with me over there. But for some of you, since you're saying the management isn't responding, I did share my number. If at all you got any questions, you can reach out to us so that I will definitely help you out in all possible ways. Yeah, friends. Yes, again, questions here. I have to make a decision regarding course. Please, sir, I want to take with you management response. Yeah, Pawan, I'll definitely, Pawan, I'll check with the management once they will respond back to you. Okay. If if still it's not working, tomorrow we got a session to join the session, and I will I'll get the management forward, and you can have a word with them directly. Yeah. Yeah. Any other questions, friends? Online candidates, any questions? Well, I would say you can add 3+ years of experience to stay, in a safe zone. If you add 5+ years of experience, you got to put effort accordingly, right? So if you are quick learner and you are hardworking and you put a lot of effort, definitely I'd suggest you to go with 5+ years of experience. But what I would suggest is it's better, since you are not at all into DevOps, it's better you can go with the 3+ years of experience once you're done with the entire course from us. Yeah. Yeah, 3+. Yeah, true. That is the reason. If at all you're done, you're doing really well in Kubernetes too, then then it's you're good to go with 5+. Right away, if you add 5+ years of experience, and if they added all the responsibilities on you, that is where again you got to suffer a bit. That's the reason I'm saying 3+. But mostly it all depends again on you, the amount of contribution you're putting. See, the other day I got a message from one of the students. He would say, with the amount of with Kubernetes, whatever the amount of Kubernetes we are teaching, he got certified in Kubernetes. He sent a message to our WhatsApp group saying, Prashant, we are happy that with the help of your trainings and some effort which I put, I'm able to successfully complete my certified Kubernetes administrator course, certification. He got certified just I think yesterday only. We got a message in our WhatsApp group. I didn't get enough time to see, but yeah. So friends, you definitely find a lot of discussions here. 80% of the course is say hands-on, and 20% of the course we have some discussions on the tools and some strategies and deployment models and all these. Okay, 80% of the course is completely into hands-on. Yeah. Yeah, again, see, these are the examples just we did cover before, where they're still beginners, but I did show them examples. How do we write shell scripts in in our DevOps journey? How to prepare scripts and run them, which are relevant to DevOps, not relevant to some basic stuff like a print 2 table or 3 table with for loop, nothing as such. Yeah, see over here, cat script 07. What is it? I did assign them some assignments too, and they got to complete them and submit them back to me by tomorrow. Scripts, even you find all these really feasible scripts. Don't worry, when you attain the same speed and you get all these successfully done, you yourself get to know all these once we get started with our course, right? Yeah. Fine, friends. If no questions, let's call it a day. Once again, give a try checking with your management. Yeah. And if at all, tomorrow also, let's try to connect the same time. And if at all there are still challenges, you are unable to get enough information from our management, then I will, I'll talk to them and get your queries addressed in their presence. Only. Yeah.
Sure, sir.
Fine, friends. Thank you. Thank you for your.
Thanks, sir.
Thank you all.